Hello guys, today is my topic about types of losses in DC machine. And as we know, energy neither can be created nor can be destroyed. It can only be transferred from one form to another form. In DC machine, mechanical energy is converted into electrical energy. During this process, the total input power is not transformed to output power. Some part of input power get wasted in various forms. The form of these losses may vary from one machine to another. These losses due in rising temperature of the machine and reduce the efficiency of the machine. In DC machine, there are broadly four mainly DC machine causes of energy losses, constant loss, various loss, no load iron losses, mechanical loss, copper iron loss, and stirred loss. Copper losses. The copper losses are the winding losses taking place during the current flowing through the winding. These losses occur due to the resistance in winding. In a DC machine, there are only two winding, armature and field winding. Thus, the copper losses categories in three parts: armature losses, field winding losses, and brush content resistance losses. The copper losses are proportional to square of the current flowing through the winding. Copper losses. Copper losses is the power loss as heat in the winding. It is caused by the flow of current through the coil of the DC armature of DC field. This loss varies directly with the square of the current in the armature with the square of the current in the armature or field and the resistance of the armature of the field coil. Armature copper losses in DC machine. Armature copper losses is equal to Ia square Ra, where Ia is armature current and Ra is the armature resistance. These losses are about 30% of total full load losses. Field winding copper losses in DC machine. Field winding copper losses is equal to If square Rf, where If is field current and Rf is field resistance. The losses are about 25% theoretically, but practically it's constant. Brush constant resistance loss in DC machine. Brush constant loss attribute to resistance between the surface of brush and contour is not a loss which could be calculated separately as it is a part of various losses. Generally, it contributes to both the type of copper losses, so there are factors in the calculation of the above loss. Core loss or iron loss in DC machine or magnetic losses. As iron core of the armature is rotating in magnetic field, some losses occurs in the core while it's called core losses. Normally, machines are operated with constant speed, so these losses are almost constant. These losses are categorized in two forms: hydrolysis loss and eddy current loss. Hydrolysis loss in this machine. The armature winding due to the reversal of magnetization of the copper. When the core of the armature exposed to the magnetic field, it undergoes one complete rotation of magnetic reverse. The portion of the armature which is under a pole after completing half electrical revolution, same piece will be under N pole, and the magnetic lines are reversed in order to overturn the magnetic within the core. The constant process of the magnetic reverse in the armature consumes some amount of energy which is called hydrolysis loss. The percentage of the loss depends upon the quantity and the volume of the iron. pH is equals to NB 1.5 maximum into FV max, where N is equals to stagnant hydrolysis coefficiency, B maximum is equal to maximum flux density in armature winding, and frequency of the magnetic reverse and volume of the armature in M3. How to reduce hydrolysis loss? To reduce hydrolysis loss, most DC armature are constructed of heat-treated silicon steel, which has an inherently low hydrolysis loss. After heat cycling steel is formed to describe shape, the lamination are heated to a dual rate and then allowed to cool. This process known as annealing introduces hydraulic losses to very low load, eddy current loss in DC machine. According to Faraday's law of electromagnetic induction, when an iron core rotates in magnetic field, EMF is also induced in core similar. The armature rotates in magnetic field. Small amount of EMF induced in core, which allows the flow of charge in body due to the conductivity of the core. This current is usually formed machine. The machine of the current is called eddy current. This value is constant for the DC machine. The formula of eddy current loss is Kb square F square T square V, where K is equals to constant, E is equal to thickness, V is equals to volume of core, and F is equal to frequency of magnetic reversal. How to reduce eddy current loss? To reduce eddy current, the armature and the fuel core are constructed from lamination steel sheet. The laminated sheet are insulated from one another so that current cannot flow from one sheet to other. Machine losses in DC machine. The machine losses in DC machine are the losses associated with mechanical effects. Mechanical losses occurs at the pinion and shaft air friction due to rotation of armature. There are two basically types of machine losses: frictional and breakage. Frictional frictional losses take place due to the rotation of the armature. These losses are bearing frictional loss, brush frictional loss, and weightage frictional loss. Weightage frictional loss take place due to the rotation of the armature in air. Weightage frictional loss is proportional to the cube of the speed. Brush frictional loss and bearing frictional loss are proportional to speed. This loss is about 20% to 30% of full load versus the practically constant speed operation. This loss too may be assumed to be constant. Bearing frictional loss generally depends on the types of bearing used and on the viscosity of the lubricant. Brush frictional loss is proportional to the constant area and the brush brush. Also depends on the other factors like materials of the brush and consumption and temperature at the constant surface. How to reduce mechanical losses? Careful maintenance can be instrument in the keeping bearing friction to a minimum. Brush friction is reduced by assuming proper brush setting, using proper brushes, and maintaining proper brush tension. A smooth and clear controlation also aids in the reduction of brush friction. Scale load losses in DC machine. There are some more losses other than the losses which have been discussed above. These losses are called stair load losses. These Mechanical losses are due to the short circuit current in the wall undergoing combination restoration of fuel due to the armature and many more losses which are difficult to find. These losses are directly to determine, however, they are taken as 1% of the whole load overall. Constant and various losses for a DC machine. Total losses equals to constant loss plus various losses. Constant losses are those losses that always occur irrespective of the load concentration and full value remains constant for a given machine. Mechanical losses, core losses and shelf failure. Copper losses are included in constant losses. Variation losses are those losses which increase as load on the machine is increased. There are electrical losses including armature copper losses, the field winding copper losses, interpolated Pole binding copper losses, communication with binding losses, and cross constant loss. State that losses due to having a fixed value there. There are some related to armature current and speed. Since they are completely to computer and are very small in value, they are mostly ignored. See, this is the table. Mechanical power input is equals to output the mechanical electric power going to the generator as this it works. In a DC machine, there are armature copper losses about 30 to 35% of full load losses. Field copper losses about 20 to 30% of full load losses. Iron losses about 20 to 30% of full load losses. Mechanical losses about 10 to 15% of full load losses. Thank you.